Hello, we will correct here the exercises of Chapter 4 concerning the mesh current method. In this exercise, you have three meshes as you can see. So you have three equation, KVL equation. You choose the direction of the currents, of the mesh currents as you wish. You place them in a standard form, you solve them, and then you will calculate the power developed by the sources. For the 230 volt source, the current is I1. It's entering the negative terminal. For the 460 volt, the current is I3. It's entering the positive terminal. For 115 volt, the current is I3 and I1. So you have to be careful. If you choose I3 minus I1, so the resultant of I3 minus I1 enters the negative part of the voltage source. So it is minus 115 times I3 minus I1. Okay, so I repeat, for the voltage source 115 volt, the current is I3 minus I1 or I1 minus I3. If you choose to consider I3 minus I1, you have to see that I3 is entering the negative terminal, so you put minus V times current. Then you can calculate the current in every resistance and you will double check that nothing is lost. For each resistance, for example, for 1 ohm, the current is I1 minus I2. Since you put it squared, so there is no worry if you put I2 minus I1 or I1 minus I2. In this exercise, you have a dependent voltage source. You write the meshes, the KVL in the three meshes, and you write the constraint equation, and you solve it. Then, to calculate the power of the voltage source for I delta, the concerned current is I2. It's entering the positive terminal. In this exercise, you have how many essential nodes? 1, 2, 3, 4 essential nodes. How many essential branches? 1, 2, 3, 4, 5, 6. So 6 minus 4 minus 3 is 3. And as you can see, you have 3 meshes. You will do your meshes. In this mesh, be careful. There is a current source, 30 amperes. So you directly write I3 equals 30. You don't have to write a KVL. Anyway, you don't have the voltage here on the 30 amperes, so you cannot write it. So whenever you have a mesh and you have a current source in it, which is at the border, so you can directly write the current is equal to this current source. Since we need to find the power of the 30 ampere, you need to calculate its voltage. So they have placed the voltage in this direction. You can choose it as you wish. You write a KVL equation in this lower mesh, in this lower loop. You have 0.8 times I3 times okay, you can write it in your own, you can write 0.8 times I3 minus I2 plus V30 plus 5.6 times I3 minus I1 equals 0, and you will get V30 equals 10.4. And the current I3 is entering the positive terminal, so it is plus V times I. For the 600 volt, the current is I1. I1 equals 35 and it is entering the negative terminal, so it is minus V times I. For the voltage source 424, current I2 is entering the positive part, so it is plus V times I. And then you will calculate for the resistances. For the resistance, don't worry if you choose the currents, I2 minus I3 or I3 minus I1, I2, since you will put them squared. In this exercise, we will choose the node voltage method. Here we have a special case. We have here a super node between 3 and 4. So here you have between 1 and 2 a supernode and between 3 and 4 a supernode. You remove it and you have as if you have one common node. You write the equations, then the constraints. Then you have to find the power of the 20 volt. The current is I0. It's entering the positive node. So it's plus V times I. How to find I0? You can write a KCL equation at 2, and then the constraint equation, for example, for V alpha. V alpha is 250 is V2, V alpha is V2, V delta is V3, and you have for example, between nodes 2 and 1, you have V2 minus V1 equals 20, and here between V4 and V3, you have 0.4 V alpha. Please note that this is a current source, it is not a special case, okay? Thank you.